Okay, so off we go to the races here. We're going to tackle this problem that I found, or student found in sample exam number 1, alternate version. This is near the top of the exams, going back to the deep archive here. We have a stereocenter on this molecule. It's R. We got to figure out where that is. And how do you start a big problem like this? Well, you draw the end of the name first, eicosane. And just to be clear on your test, you won't have boxes. You'll just be given the name and told to draw it on your sheet of paper. So we'll draw it underneath the box here. Eicosane is 20 carbons. Stick figures: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And I always verify. I never trust myself. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we got our eicosane moving along smoothly here. On carbon 2, there's a methyl. Here's carbon 2. On carbon 18, which is, 18, 19, 20, there's an ethyl. We still haven't seen a stereocenter. Why is this not a stereocenter? It's because it has 2 identical methyl groups. Why is this not a stereocenter? It's because it has 2 identical ethyl groups. You need to have 4 different groups to be a stereocenter. My suspicions are that carbon 14 is a stereocenter. Let's verify that. Carbon 2, 4, 6, 8, 10, 12, 14 is right there. Here's how I tackle drawing stereocenters. Oh, I lost track of where 14 was. How about this? 20, 18, 16, 14. It's right here. Good. That's a stereocenter. I haven't put the groups on it. I haven't put wedges and dashes on it, but I must do that if I want full credit. On a stereocenter, I need to see all of the groups. This is where you can't skip any H's if there are some. How do you draw a 2,2,4 trifluorobutyl group off of this carbon? Well, you start by drawing a butyl group, which is 4 carbons long. 1, 2, 3, 4. Then on the second carbon off of the chain, so there's the first carbon in the group, that's carbon number 1. In the butyl group, this is carbon number 1. You don't invent your own rules. That's carbon 1 in the butyl group. Carbon 1, carbon 2 has 2 fluorines on it. 2 fluorines. And carbon 4 also has a fluorine, carbon 4. And here you must show this H, because a stereocenter, I need to see a couple things. I need to see all 4 things. I need to see 1 wedge and 1 dash. I need to see the wedge and the dash on adjacent bonds, because that's the only proper way to draw a stereocenter. I will review what I just said after I finish. Right now, we have to do the priorities for the stereocenter, 1, 2, 3, 4. And the priority 4 is definitely a hydrogen with the lowest mass. It's the lowest massed atom attached to the stereocenter. We have a 3-way tie for the highest mass: carbon, carbon, carbon. This is a CH2, as is this, as is this. They are still tied up to this point. You go to a second carbon with an F, and a second carbon, what's the heaviest thing on this second carbon? A C. What's heavier? An F, mass 19 grams per mole, or a C, mass 12 grams per mole? Answer: F is heavier than C. That F is being compared to this carbon, the same distance from the stereocenter, making this group a higher priority. Which of these 2 groups gets to be number 2? Well, there's CH2s how many times going this way? 1, 2, 3. They tie 1, 2, 3 CH2s going this way. Then you go to the 4th C here. Ask yourself, what's the heaviest thing on that? A C. The fourth C over here. 1, 2, 3, 4. The fourth carbon, what's the heaviest thing there? A C. We're still tied. Back to the fourth carbon. What's the second heaviest thing? Another carbon. Now going back over here. 1, 2, 3, 4. Heaviest thing was a C. It was tied with the one carbon from the previous comparison. Does it have another C? Answer, no. You're comparing an H over here. An H off the heaviest carbon, the fourth carbon, with a second C on this fourth carbon. This is the winner. Therefore, this is number 2, and this is number 3. And here's the strategy. You have the 4 groups. You connect the 4 groups with a circle. I want to get everything except for that box. Moving on. I'm going to keep it step by step. You do not have time to do. Oh, I got the box. Here we go. Everything without the box. Thank you. If you connect 1, 2, and 3, and you get what the question asks for, then you're going to put the number 4 group on a dash. This is clockwise, which is R. That's just what I said. If you connect 1, 2, and 3, and you get what the question asks for, clockwise being R, you put the number 4 on a dash. And an adjacent bond must become the wedge. You have 2 choices for wedge. They both give a correct answer. You have one choice that would be a bad answer. You would get the comment illegal tetrahedron minus 0.5 points if you made this a wedge. Fact, tetrahedrons don't look like that. The wedges and dashes are on adjacent bonds. You can pick this bond or this bond. Doesn't matter which. I'll pick this one. Make sure the wedge goes all the way to the end of the bond. If that's another thing, if it stops halfway, I'm going to give you a minus half point again and saying, I'll say your carbon now has 21 carbons in it. Trust me, you just added a new carbon right here where this wedge ended. There's a bond from here to here. This is not a sufficient wedge. It has to go to the end. There you go. So you got full credit for this. Now, to make this a thoroughly educational problem, pretend the question was, I don't want them overlapping here. Oh, I thought I copied it. I didn't. Huh. Very strange. Copy paste. There we go. We're going to end this segment here very soon. And I'm just going to do a quick edit here. Start all over. Wonder if I can make it even look like it was there all along. I doubt it. Italics, Times New Roman doesn't show up. Tahoma. Arial. I don't want to waste too much time here. Too late, you're saying? Okay. Pretend the question was S to start with. So all the steps you did earlier are still valid. Everything valid. This is not S when I was done. So all the work up until here is the same. I'm going to put the blue bonds back. You got the wrong answer if you do what you did up here. Oh, I did erase. Okay, I'll fix that later. You got R and your question is now S. There's an easy fix for that. If you have the number 4 on a wedge, then the direction of the circle gives the opposite to the real answer. It's as if now you're standing behind the page and that H is on a dash if you're behind this page, and that direction won't be clockwise for you anymore. It'll be counterclockwise. Prove me. It's in other, trust me, it's in other videos that I proved this, is what I wanted to say. So this would be S. And let's just make sure we're not covering up our beautiful first answer. There we go. And that was a good segment for this molecule. If you have a question, Hassan, let's please go ahead and ask right now.
So the S and the R, like it changes, that's basically just what changes, like the wedge and the dash.
Well, you got to watch all of the videos and read the textbook about how to do R&S. And what I gave you down here was just a trick that works for every scenario ever. Draw the bonds normal, connect the 1 and the 2 and the 3. If it matches the direction, that is clockwise means R if the 4 is on a dash. Counterclockwise means S if the 4 is on a dash. If it matches what the question has, put the 4 on a dash. If it doesn't match what the question asks, here it's clockwise. Here it says it needs to be counterclockwise. Doesn't match. Put the 4 on a wedge, and an adjacent bond gets the dash. Whatever you're looking at, this direction here means you're getting the opposite answer. It is not R, therefore it is S.
It's S. Okay.
It's a trick I'm teaching you. It's not chemistry that I taught you just now. There's thousands of ways to draw stereocenters. There's thousands of approaches, but this is foolproof, and it works every time. You don't have to worry about rotating molecules in your head. Well, about 5% of the population has that ability. That's maybe a high estimate. I'm not one of them. So this technique gives spatially challenged people like me the ability to do R&S on any stereocenter, anytime, any place.
Okay.
All right, and we'll move on to the chair drawing question after we take a little break.